Alright, so let's get started on the week 9 electrical activities for Engineering 120. We're talking about relay activation and powering other loads. Again, we're working on an application of cascaded switching. Again, that's using a low energy system to turn on or trigger another system. The UNO 32 digital output voltage will activate a relay, and it closes a switch inside that relay that turns on other loads. So the loads that we're talking about for our fish tank control system will be a tank heater and the 2 solenoid valves that will be used to add deionized water and salt water in a few weeks. So again, cascaded switching, a typical circuit we're talking about here, shows the UNO 32, its digital output, and that step function right there, this is indicating that we'll be turning that on and off with the microcontroller. And this is the primary circuit. We go through a resistor, down through the coil of the relay. The relay includes the coil that pulls, the magnetic field pulls in the switch and closes it, and so that makes up the primary circuit. Again, this magnetic relay provides some isolation between the activation circuit and the load circuit. So again, you'll see here that the primary circuit is just a simple circuit, has 2 resistors in it, and this current limit of 6 milliamps actually comes from the relay coil. That's all it needs to activate. There's also a limit on the UNO 32 that you'll be checking out and doing calculations on to find out what this resistor is. This is the resistor we have control over. This magnetic relay has a fixed resistance you'll measure and read off the data sheet, and then you'll check the current limits on the UNO 32 as well. So the whole goal here is to choose R to protect the UNO 32 and to operate the relay. So on the secondary side, when the switch closes, the external power supply allows current to pass through our load. This is our our secondary circuit that drives the loads. We have another circuit attached here, but this is just going to provide us with the ability to power on a light so we can tell when things are on and off. So an LED is what we're going to use for our lamp this time. So on this side, the goal is to check the power supply against what's available on its label and what power does each load need. So during today's activities, you'll put in the heater, measure its current, put in the 2 solenoid valves and measure their current as well. We'll also be doing a calculation here to protect this LED. So let's move on here. So just a little reminder about the breadboard work that we did in week 8. The edges are usually used for power supply connections. In our case, the red top line will be used for 12 volts. The blue top will be used for 0 or ground, all of these for the external power supply. So that external power supply connects to the breadboard through a fuse that protects things. Oh, look at a little missing text there. And it provides 12 volts to the red and ground as it said above. And these are horizontal connections. Let's talk about that real quick. So again, we'll be powering the breadboard through the power supply shown here. And it comes through and then through a fuse. Again, the plus side, or red, will come down to the breadboard and plug in, and the black to the blue. So that means all of these dots going along to the right, all these holes here are 12 volts, and all of the blue side are ground. And so that's the breadboard setup. On this side, we'll be having the UNO 32 provide ground on this side and power later on in the semester here. So let's take one more look at our circuit and get started. So again, the goal here is for the primary circuit, and keep in mind we want you to understand the difference between the primary and the secondary circuit. You're going to choose R to keep the current high enough to activate the relay and low enough to prevent damage to the UNO 32. So again, we're going to apply Ohm's law that we practiced in week 8. We want you to look at the UNO 32. Each digital output provides 3.3 volts. Now, we want you to check the UNO 32 data sheet for a typical current. It's available in the reference materials. Take a look at it and find out what's available on each digital pin, what it should be, typical operating current would be. Also, there's a relay data sheet, and you should be able to check for the resistance of the coil, and then also measure the resistance of the coil to get some practice there. And so you'll have the resistance, the expected current, and the voltage, and with that you should be able to work out what the resistance that you're going to add is to limit the current. So here's the equation. You'll see a little bit difference here. We've got voltage is current times the total resistance, so we added it up. But there's only one unknown here. So run through this with the values you get in class and solve for R, and that'll be the resistor we're going to put right here in the series circuit. So I'm going to go ahead and wire that up right now. So as we do that, this is the relay that we're talking about. You see it has 4 terminals. The outside terminals are the switch, and the inside terminals are the coil. If you look at the circuit diagram, the layout diagram here, you can see the switch is connected to 1 and 7, and then the coil is connected to 3 and 5. This has an extra diode. This is what this symbol is for a diode. It prevents current from flowing backwards through it. And so we'll want to make sure that we connect our plus coming from our UNO 32 to this point right here. I'll emphasize that more as we wire it up. All right, let's take a look at the wiring. Again, we've got our relay here, and we'll slide it in. It's going to have to be above the center line, so we're going to take it one step above the center line. And now we need to provide, if you look at it more closely, let me hold that up. You can see the pins on the left is 1, the second pin is 3, the third pin is 4, and 5, and then the last one is 7. Again, 1, 3, 5, and 7. All right, so we're going to go ahead and put that in here. So to complete the first circuit, we're going to need to go from the UNO 32. So if we back up and look at the UNO 32, just like with your motors, we take digital outputs to the board. We're bringing ground out here and brings it down to the terminal block. So we'll set ground. We'll hook ground in. As I get my coordination back here, there we go. Ground, come out, and we're also going to need one of the digital outputs, and we're going to use the white one and try and keep the wiring consistent so it's easy for everybody to help everyone troubleshoot. So we've got 12 volts coming from a digital output. We're not using red because this is a controlled signal. No, sorry, 3.3 volts, sorry. We're not using red because it is a control signal. And so the ground is going to come in and get placed in the lower section of the edge, and the 3.3 volts or digital input is going to go into one of the lower sections. Now, I selected a resistor to demonstrate the circuit wiring. You're going to have to decide what resistor to use. I'm going to come from the same digital input into the pin 1 of the relay. Now, that gets us into the relay. Now we have to come, into not pin 1, pin 3, because that's where the coil is. So we're going into the coil, and we need to come out of the coil to ground. So the other pin is pin 5, which is the third one over, and we'll bring it back to ground. So again, we're coming out with the digital input, through the resistor, through the coil inside the relay, and then back to ground. So that represents the primary circuit coming from the UNO 32 around and activating the relay. All right, so let's move on to the secondary circuit. Again, these are going to power loads and add an on LED, a light emitting diode, to show when things are actually working. So the goal is to connect and measure the power to each of the loads that will be used in our system. And the second goal is to choose the resistor to limit the current going through the LED. They burn out easy when they're not protected. If you don't add a resistor, they won't last very long. They're not intended to carry a lot of energy. That's why you see a lot of LED lights being made, low energy. So we're going to complete the secondary circuit, and then we're also going to apply Ohm's law for the LED resistor selection. So the LED datasheet shows a safe current of 12 milliamps. The LED itself, when it's operating, has a 1.4 voltage drop across it, not very much. And the voltage from the power supply that's coming around that gets applied over the across this is 12 volts. So rearranging Ohm's law, solving for the LED resistance, we've got the voltage across the resistor on the LED is going to be 12 volts minus the 1.4 drop on the LED divided by the 0.012 amps, or 12 milliamps. So complete this calculation, and now this will provide us an on indication with that wiring complete. So we're going to do the first circuit that activates the load, and then we'll add the LED in. All right, so we're going to come out of the power supply through the switch, out of the switch, out to the load, and then back to ground. Okay, so again, our power supply is here. We want to come out of the power supply and into the first side of the switch, and that is pin 1. We're going to connect it to the column that's attached to pin 1. All right, so then the switch comes out on pin 7 out here on the end, and that needs to go out to our load. So I'm going to add the resistor here, add the wire here, excuse me, and come out of the switch right here on the end. Okay, so that's coming out of the switch, pin 7. All right, so then it needs to go, it goes out through the wire travels up here and comes to this point, and we're powering the heater right now, and so then it goes through this resistor and comes back. Okay, through the resistor and then back out, comes back to here. So since this is the 12 volt power supply, we're going to use a slightly different color for ground. We're going to use the green just to keep things consistent, green for the secondary power ground and black for the, and we have to come right back to the ground. So again, we came out of the power supply through the switch, out through the load and back to ground. So that closes our secondary circuit. So that'll work, but we can't really tell when it's on, because when the heater's on, you'd have to touch it to tell. So let's add the LED. The LED has one leg longer than the other. That's the positive leg, and that's the one that needs to go into the positive of the 12 volts on the switch side. We can just jumper it over to another column. So we went from the positive over a couple of columns, and now we have to go through a resistor. Remember, this is another resistor you guys have to choose. And from there, we need to go to ground. And so I'm going to bend that up a little bit, insert it in ground, and in that same place. So now we've got the LED from 12 volts after it's switched through the LED, through a resistor to protect it, down to ground. So now we should be able to power up this and watch the lamp come on and indicate that things are up and working. So we've got everything set up right. All right, so we did have a wiring problem. It's easy to get it off. We were on pin 6, what would be pin 6, which is a vacant. We had to move it over one where the LED comes out. I'll bend this back just a little bit, bend this one over. So we went from 7 out through the LED and then over to ground. And the program we've got running turns on the digital output for 8 seconds and then turns it off for 1 second. So you'll be repeating this in class, selecting this resistor, and we should be ready to go. Now, the other part that you'll be doing in class is actually measuring the current that's being drawn by the heater. So if I pull the heater down here and kind of grab it lightly, I can tell that it's getting warm. Okay, so be careful in class. We'll also be doing the solenoids, and they'll make a nice clicking noise when they're working. So that's enough to get you started on the wiring this week. Good luck. We'll see you in week 9. Okay, one last thing, the key ideas for this week. Data collection. Use spreadsheets to capture the data and complete the calculations. On the metering, get comfortable choosing the meter setting based on what you know or can measure. The UNO 32 circuit, or the primary circuit, is low current. So make sure you understand how to make the settings set, and make sure you understand which part of the circuit is the primary circuit. Heater and solenoid circuits are the secondary circuits, and they're higher current. So make sure and change the meter settings as needed, and then change the meter wiring as needed so that you're measuring in a high current thing. Again, this comes back to knowing how to set up your meter and when to set it up to measure high current and low current. I recommend you work it out as a team first and then ask for verification before you get started. We prefer not to blow as many fuses as we can, but it's an experience. Ask us first, and you can get reassured by us. Again, this is a skill. Make sure everyone knows how to set up the meters and measure voltage, resistance, and current. At the end of the term, we'll have a practical exam, and you'll wish you'd learned while we were doing it. So again, good luck. We'll see you in week 9.